differentiation and to integration and the application. So the process of calculating the derivative of a function is called differentiation. I'll take it again. The process of calculating the derivative of a function is called differentiation. Let's take a look at this graph. If you have a graph like this, this is the y-axis and x-axis, and we have a curve. Okay, if we have something like this equals to x squared, the relation y equals to function of x. This implies that y is a dependent variable. Yx is independent variable. This implies that y depends on x. Okay, we want to look at the techniques of differentiation. The first one is standard derivatives of some basic functions, which are the general rules which can be used to solve our differentiation problems. And two, we have differentiation from first principle. But all these general rules too can be derived from the first principle. So let's start with the general, or let's consider rule 1. Rule 1. If y equals to x to the power n, using general rule, then dy with respect to x, so dy dx equals to, this n will come down, it will now be n times x to the power n minus 1. The n, which is the power, will come down, multiply the x, and minus 1 from the power. So from there, it will now be, to round up this, dy with over dx equals to n x to the power n minus 1. That's the first rule. So rule 2, if y equals to ax, this x is not standing alone, it's x to the power 1. Just that in mathematics we don't used to write 1 as a power. So then, using the first principle, then dy with respect to x, which is dy dx, equals to, the 1 will come down, now be 1 times ax, 1 minus 1. You have to minus 1 from the power. So, therefore, our dy dx equals to 1 times this is ax raised to power 0. 1 minus 1 is 0. So, dy dx equals to, then to the power 0 is what? 1. That be a times 1. Therefore, dy dx equals to a. That's rule 2. So let's move to rule 3. Let's consider rule 3. If y equals to a there is a constant, then using first principle, dy dx equals to, okay, let me try and analyze this. This a is having x. So, but the x is 6 power 0. What makes this to be equal to 0 is this. This 0 will come down to now be 0 times ax 6 power 0 minus 1. Therefore, the y dx, no matter how, if you multiply 0 with anything, it will surely give you 0. So 0 times everything here is what? 0. This implies that differentiation of a constant must surely give us 0. Rule 4. If y equals to cos raised to power n, cos can be any expression but inside brackets. So the y dx, using first principle, will be equals to, we bring down this power n to be n times derivative of the core times core raised power n minus 1. So rule 5, if y equals to sine x, using general rule, then dy dx equals to cos x. Very simple. Let's move on to rule 6. Rule 6. If y equals to cos x, using general rule, then dy dx equals to minus sine x. All these things are provable using first principle. Look at rule 7. If y equals to sine ax, here there's not a constant. That's very different from this. Not constant here, but there's a constant here. Using general rule, dy dx equals to the constant will come out. A definition of sine will give what? Cos. Cos ax. I believe you are going with me. So let's look at rule 8. Rule 8. If y equals to cos ax, still make use of the general rule, then dy dx, this will come out. But mind you, if you differentiate cos x to give minus sine x, so for cos to change to sine, there will be minus, the constant will come out and it will now be sine ax. For the purpose of this class, let's look at the last rule, which is rule 9. If y equals to exponential x, so dy dx equals to exponential x. It will not change. We're still going to consider other general rules, but for the purpose of this class, we just want to look at it from rule 1 to rule 9, which we are going to use to apply in solving questions. So let's consider the first principle. Let's consider this example. Find the differential coefficient of a function below with respect to x using first principle. This is the function. So firstly, I'll write the solution. Y equals to x. One thing about differentiation is that it deals with changes. Y is a dependent variable, while x is independent variable. So this will now be y plus del y equals to x plus del x. So from here, we have to what? Lift our y up, take it to the other side. Now be del y equals to x plus del x minus y. Then recall that y equals to x. So let's substitute our y to be x here. To now be del y equals to x plus dx minus x. Oh, x will cancel x. Del y equals to del x. So from here, let's divide through by their hands. Divide through by the x. So to be the y over the x equals to the x over the x. This will cancel this, which is going to be 1. So the next we're going to do, we are now going to turn this to dy dx by saying which is equals to the y over the x as the x tends to 0. We are finding the limits of this as the x tends to 0. We return to dy dx, which is going to be what? 1. Therefore, the y over dx equals to 1. I believe you understand this. So let's consider another example. Example 2. Find the differential coefficient of a function below with respect to x using first principle. Look at this now. Y is equals to x squared. So if I have to apply general method or general rule, I'll just say that y equals to x squared dy dx equals to, the 2 will come down, 2x, 2 minus 1, which is equal to 2x, 2 minus 1 is what? 1. This is the answer. But we are not asked to use general rule. We have to make use of the first principle. So how can we go about this using first principle and we still get this? Well, let's start. Y equals to x squared. So y plus the y equals to x plus the x squared. We need to square it. Okay, let's continue. Y plus the y equals to x plus the x into x plus the x twice. So we're going to expand this bracket. So y plus the y equals to x times x, x squared, plus x dx, dx times this, plus x dx, plus dx squared. So let's tidy up this. Y plus the y equals to x squared plus 2x dx plus dx squared. What's the next thing? We have to take our y to the other side. So it will now be the y equals to x squared plus 2x dx plus dx all squared minus y. Then we call that our y equals to what? X squared. So from here, and now say that y equals to, the y equals to x squared plus 2x dx plus dx squared minus, so writing y, we need to write what? X squared. Oh, you can see something I'm saying? This, we cancel this. So the y equals to 2x dx plus dx squared. The next thing we're going to do is to divide through by the x. So let's do it. Divide through by the x. So it will now be the y over the x equals to, let's bring out our dx here. The x into 2x plus the x divided by what? The x. So we have to divide by the x. So the x will cancel the x. So the y over the x will be equals to 2x plus the x. So we have to find the limits of this as the x tends to 0, which will give us the y dx. But the limit of the y dx as the x tends to 0 will be equal to that. Anytime you see dx, we replace it with 0. It will now be 2x plus 0. Therefore, our dy dx equals to 2x, which is the same thing as this. Another example, find the differential coefficient of a function below with respect to x using first principle, but in this case, it's in form of fraction. So how can we go about this? Let's go. Y equals to 1 over x squared. So to be y plus the y equals to 1 over x plus the x squared. From here, it will now say y plus the y equals to 1 over x plus the x plus the x, since it is square. So let's expand this. Y plus the y equals to 1 over x squared plus, from the previous example, 2x dx plus dx squared. Okay, so from here, what I need to do, we take this y to the other side. So it's free. The y equals to 1 over x squared plus 2x dx plus the x squared minus y. So from here, we have to clean this. This a little bit longer than that one, the solution. So it will be, recall that y is equals to 1 over x squared. So therefore, the y will be equals to 1 over x squared plus 2x dx plus the x squared minus 1 over x squared. Okay, so from here, what I'm going to do, we're going to find the LCM. So let's find the LCM of this. The y equals to, what is the LCM? The LCM is x squared into x squared plus 2x dx plus the x all squared. So this is LCM. This and this remain this, that's x squared minus, into bracket we have x squared plus 2x dx plus the x all squared. Okay, so what's the next thing we're going to do? We have to remove this bracket. We use the minus to multiply everything inside the bracket. So the y will now be equals to x squared minus x squared plus, plus times minus 2x dx minus the x all squared over x times this, x is power 4 plus 2x squared times 2 plus 1, that's 3 dx plus x squared dx squared. So this will cancel this. Okay, it will now be dy will now be equals to minus 2x dx minus the x squared over x is power 4 plus 2x cubed dx plus x squared dx squared. The next is to divide 2 by dx. Divide 2 by the x. So the y over the x equals to, let's factorize our dx out from here. The x into minus 2x minus the x over x is power 4 plus 2x cubed dx plus x squared into dx squared divided by dx, which we turn to times 1 over the x. So the x will cancel the x. So from there, it will now be dy over dx equals to minus 2x minus dx over x is power 4 plus 2x cubed dx plus x squared dx squared. So from here, what we're going to do, we are going to find the limit of this as the x tends to 0. So we find the limit as the x tends to 0. So let's do that. So we now find the limit. So that means find the y dx, which is equal to the limit of the y over the x as it tends to 0, which will be equal to minus 2x. And I see the x, we turn the x to 0, minus 0 over x is power 4 plus 2x is power 3 into 0 plus x squared into 0 squared. So from here, our dy dx will be minus 2x into x to the power 4 plus 0, this 0, and this one too is what? Is 0. So from here, dy dx equals to minus 2x, this x is its power 1, divided by x is power 4, because what? Minus 2 x power 1, division will change to minus at the numerator, which is minus 4, because what? Minus 2x is power what? Minus 3. This is the answer. But let's check using general rule. Let's check using general rule. Using general rule. That is y equals to 1 over x squared. Y equals to x is power minus 2. Okay, so this over 1 over will change to minus. So the y dx equals to these two, using the first rule. We move to the back, now be minus 2 x power minus 2 minus 1. Therefore, the y dx equals to minus 2 x power minus 3. It's the same thing as this. This is the general rule. Very straightforward. It's good for objective questions. But anytime you have been asked a question like this in theory, I will point you should use the first principle. Well, I want to thank you specially for watching this video. If you have any question or suggestion,